Just how you solve them is going to be a chapter 4 concept, which chapter 4, they call them systems of equations, and you graphed them before in chapter 4, section 1, but 4.2 and 3, the algebra we just came from, as long as you've got the equations, then you solve it the same way. So the solving is not an issue. It shouldn't be the issue. Getting the equations is the hardest part. That's what I'm going to try to train you and show you. And the very last thing, you're trying to give me a sentence. This is group quiz, by the way. Remember, final exam, you pick the right answer. But the group quiz, I'm expecting if you pick the word problem or two or whatever, if you're choosing to do that, then I expect these 4 steps. I expect this. Step 1, 2, 3, 4. I expect that. If you leave off writing your answer in a sentence and all you do is just x equals 5, then you're not going to get full credit. If 5 was this answer, you'd say, well, the person was jogging. The person jogged 5 miles per hour. So the 5 is representing a rate of speed, a rate of walking, jogging. So that's what we're going to do. I got 10 problems today. Should be able to get to all of them, actually. And then afterwards, then Jan will be around to, Jan, you can probably just go in the book and randomly pick some problems, even homework problems that were assigned in the section.
Yeah.
And I think guiding them, Jan, in the setup of the equations, what's your thought process? Because once you get the equations, then I think our students would be able to know how to do the algebra and wrap it up. So just the setup. Unless you've got plenty of time and there's only a couple students, and then you can do whatever you need. But
yeah, okay.
Okay, first problem, first example. We have to have 2 variables. Most commonly, everybody picks X and Y. So you can pick any letter of the alphabet that you want, but most commonly X and Y. So that's what I'll do. I'll do X and Y. 2 variables, and you have to come up with 2 equations. The first problem is meaningless. Numbers. Who cares about numbers? They have nothing to do with anything. But it's the process that is kind of one of the easy problems to set up the process. So you got 2 numbers. Do you know what the 2 numbers are? Nope. So you let X be one of the numbers, like the first number, the biggest number. Y be the other number, the smallest number, the biggest number. 2 numbers whose difference is 50. Okay, so I'm going to say X is equal to one of the numbers, 1. Now, if they were identically the same, wouldn't the difference be 0? So they're not the same. So one's bigger than the other. So I'll say this one's the big one. And then Y equals the small number. So that's step number 1. Tell me what your variables represent in as much detail as necessary or possible. X equals 1 of the numbers that was given in example number 1. Too much detail. This is enough. Okay, first sentence. Well, there's only one sentence, actually. First part of the sentence, sum means add up. So here's what you could do. The 2 numbers, oh, didn't I say difference? I apologize. I said the difference would have been 50. No. I think I said if the numbers were the same, the difference would be 0, not 50. But the difference is actually 22. My mistake. The sum is 50. Now the difference is 22. Now, because I told you that X is the biggest, you don't want to go y minus x because that would give you a negative number. You want positive 22, big minus small, big minus small. And that's step 2. This is step 1. This is step 2. And to me, that's the hardest part. Hardest part. That's the hardest part, in my opinion. Okay, hey, now what? Substitution and elimination. Jan, let's see, just look at a show of hands. How many of you want me to do substitution? Show of hands or the emoji hand.
Let's see.
What do you see? Substitution. Let's see. Majority rules.
I see so far 2 substitution, but
Okay.
a lot of people don't have their cameras. Oh, Russ, do you want substitution too? Yeah, Russ, 3. Do substitution.
Okay, so have them raise their hand for elimination.
Okay. 1, I don't, Annette, what are you raising your hand for? I don't know. Okay. 2, 3, 4, eliminate. It looks like elimination.
Okay.
Elimination.
All right. My choice as well. Because I'm going to do it fast. 2x eliminated just like that because you add straight down equals what, 72, and then x is equal to 36. Done. One of the numbers is 36. Oh, the big number. The big number is 36. Done. See, substitution, Russ, and the other 2 people that wanted substitution, probably it wouldn't have been a bad thing, but it would have taken 2 or 3 more steps and more work. So if you guys like substitution, go for it on the group quiz and on your homework. No problem. You can just forget the elimination altogether. I'm not going to force you to do one over the other. Okay, now what do you do? Step number 3 is solved. Step 3 is solved. That's what I'm doing. All right, so now I go over here and I pick either original. All right, I'll pick the first just because it's first, which is x plus y equals 50. So that means 36 plus I don't know is equal to 50. 2 numbers add up to 50. This has got to be what, 14. Y equals 14. So add them up, 50, looks like it. Difference is 22, looks like it. So the last step, which is number 4, step number 4, where do I put that? Down here, I guess. I'd say the 2 numbers are, find the 2 numbers. Okay. The 2, or just the numbers are, I'm okay with that. The numbers are 36 and 14, period. Jeff, that would be nice if they're all that easy. Yeah, wouldn't it be? Not going to happen. But hopefully you'll find out the end of 10 problems. Some of them are not bad and others are kind of challenging. Okay, this one. Let's see. What are they asking me to do? Kids and adults. See how many kids and how many adults. I'll go right to the end sometimes and say, what do they want me to find? All right, well, what x is equal to the number of kids, the number. All right, now I'm going to go back and read the problem. Okay, you got a weekend fair, you got tickets, $5 for the kids, $7 for the big people. All the money that was brought in was that amount. And all the people that came were 587. That's all the kids and all the adults. Doesn't it sound like you're going to add 2 things together, all the kids and all the adults? All the kids and all the adults There are 587 of them. There's an easy equation that came out of that. Now, the thing I haven't used is the money. So if there were, let's say I use the number 10. What if there were 10 kids and it was $5 for every kid? You'd be bringing in $50. 5 times 10 is 50. So the setup for this, for the money, would be $5 for every kid. $5 for every kid via multiplication. You're multiplying $5 times how many kids. In like manner, you're multiplying $7 for every adult, and then all the money. Oh, show me the money. What movie is that one? Show me the money.
Jerry Maguire.
Hey, very good. Wow. All right. 3, 3, 7, 9. All right. So that's the hard part. The thing is, with the hard part, if you get this wrong, at the end, it might fall apart, meaning you get some weird answer. I'm going to tell you right now, the answers are likely going to be really nice numbers, like integers, likely, most all of them. On rare occasions, you might get like a 7.5, like 7.5 miles per hour. And that kind of makes sense in the word problem, but most of them are going to be nice numbers. If you get a weird decimal, you did something wrong up here, most likely. And most likely it's one of the equations, and most likely it's the harder one. Usually you get a nice easy one, x plus y is equal to something, or x minus y is equal to something. Usually you get an easy one. That's the hard one. Okay, let's do the same survey, Jan. Substitution, elimination. Let's start with substitution. How many hands want substitution that are interested in seeing that?
Let's see. I don't see any substitution hands.
Well, then maybe nobody cares. How many hands wants elimination?
Okay, let's see. 1, 2, 3, 4, and then I don't see any videos or 5. Wait, what was that? 5, 6. Yeah, Quinn's clapping. Looks
Okay,
like
good.
that's
Okay,
yeah.
Quinn. Okay, Quinn. What do you want to eliminate? Let's see if he's not willing to turn his microphone on. I'll have him put it in the chat. Which variable to eliminate? X or Y? You got a 50-50 chance. Pick something.
Are you there, Quinn? Oh, sorry, mic is not working. I picked
That's right.
Y.
She can chat. Just tell me which variable.
She picks Y.
Picked
Oh,
Y.
good. All right. So, Quinn, how are you going to eliminate the Y's? What would you do? Let's see if from a couple days ago it made sense to you. How do you eliminate the Y? What would you do? What's your step? You can type that in the chat too. Which I can't see the chat in my mode of teaching right now. I can't see my chat.
I can see it, Jeff.
Yeah. And if you don't know, Quinn, no problem. I'll have Jan pick on somebody else.
Total minus X.
Okay,
That's what
you're wanting substitution, Quinn, by doing that. That when you gave me total 587 minus X, you're setting it up for substitution. You said elimination though. That's in standard form, so we're good for the first step. Standard form, yay. X's are first, Y's are second. Any response from Quinn, Jan?
yeah, no.
Okay. Nope. Okay, pick on somebody else.
Randy. She's gonna hate me forever.
I was like, I knew you were gonna do that. I don't know if I'm correct, but I think you would multiply. But
Okay, multiply. You got the right word. Okay, so what are you going to multiply into what?
Oh my God. Well, you would multiply the variable, or you would multiply, let's see. Oh my
Which-
God.
Okay, which?
587.
Oh, say again. You might have said it.
587
Okay.
times.
Are you gonna pick the top equation or the bottom equation to multiply something to it?
It would be the top.
Okay, so far you used the word multiply, good, and it is the top. That's what I would do as well. So what are you going to multiply the whole top by so that you eliminate the y's? We're back to Quinn. Quinn wants the y to go away.
Oh, we're eliminating y.
Yeah. Yes.
Well, if you're, it would be, it would be, I don't know, 587. Oh, so you would take the whole thing and put it in parentheses.
Okay.
Because
I want to eliminate the y. Okay. I'll give you a little hint. You're going to add straight down. I want to eliminate the y's, but I can't right now because that's only going to give me 8y. What are you going to multiply up here to distribute so that the y's go away?
Oh, that's right. Yeah, because you, would it be 7?
You're okay. So right now you said multiply, thumbs up. You said first equation, thumbs up. You gave me a number, thumbs up. Now I've got one more question. Positive 7 or negative 7?
Oh, a negative 7.
Well, she's got it. Good. Just need a little guidance.
Yay!
Winner,
Wow,
winner, chicken dinner.
Oh my gosh, sorry that took so long.
That's okay. Now for the rest of you and Randy too, now you distribute like this and we get negative 7x, subtract 7y. That's a good thing. That's what we wanted. Equals negative big number, 9, 4, 56, 0, 6, 35, 40, 4, 1, 0, 9. I did that real fast in my head.
Yep, you got it.
You know, mental arithmetic, I don't know. When I retire, I'm still going to do the same thing because I think it'll keep your brain working good. What did I do? 7. I said 7. Okay, that's 49. I went 9. It's got to be here. 4. Add, that's 56 plus 4 is 60. So I put a 0. And then 35 plus 6 is 41. See, that's kind of how I did it, but I make mistakes every once in a while. So it's not like, oh, wow, he's so good. No, I just keep practicing mental. Now to do mental arithmetic with the 2-digit times something, I wouldn't do it. With just a single digit, I try to do that. Anyway, that's me. So Quinn, this is what's happening. See, you picked the y's, and that's how we eliminate it. Is you got to make the numerical coefficients of both of them the same. See, they're not the same right here, but it's an easy thing to make. This is just a 1 right here. Easy to multiply that by something very simple, negative 7 in this case, but everything has to be negative 7. Then you get negative 2x, and that gives me, let's see, 0, 3, borrow 10, 7, 730. Is this number minus this? Oh, negative 2, by the way. What do you, someone check me. Okay, fine. You're
Yeah, oh, I got you, Jeff. Yeah,
my count. Nope, I'm sorry. Too late. I'm going to do it myself. I'm going to answer my own question. You guys are just too slow. You just want me to, don't trust what I'm doing because I make mistakes. All right.
I did it. I told you.
No, you didn't. You weren't loud enough. You had your microphone off or I was
I
deaf.
did.
All right, x is equal to half of this, which would be 365. I don't know, 365.
Yeah.
All right. So, oh, the number of kids. There it is. X. Okay, so there were 365 kids. And the leftover is the adults. So you could just take 365 and subtract it from 587, which is probably the easier of the two to check, by the way, or plug it in. Not this one. This is too much work. So if you want to do this, you go 365 plus the y equals 587. Y is the difference.
222. Room 222.
Yeah, I remember that movie. Yeah, that was
Oh.
actually a series.
With Karen
Television.
Valentine.
Yeah, some people don't know who Karen Valentine was. Okay, what do you remember, Jan, as the actress Karen Valentine? Where did she come from? Where did she live?
Sebastopol. She lived in Sebastopol.
Right. She went to Annalee.
Yeah.
She was the famous actress, but I think that's the only thing I remember her in is that series that probably lasted 2 years or something like that.
Yeah.
My sister went to school with her.
Oh, really?
Is she still with us? Is she still alive, Russ, as far as you know?
I don't know if Karen Valentine is. My sister is.
Yeah, well, sorry, I didn't mean it that's right. I was a little ambiguous and I apologize that I didn't even mean to laugh that way. But yeah, Karen Valentine is what I meant to say. Is she still with us?
I don't know. I really don't. I haven't seen her in years.
Yeah.
Yep, she's still alive. She's 73 and it says she lives in Sebastopol.
Really? I'll be darned.
Yeah. Oh, no, she's born in Sebastopol. Yeah.
Right.
Anyway.
Yeah, I do know she went to Annalee. So.
Okay.
All right, next example is that the old distance, rate, and time kind of problems you might have heard or experienced in the past. Distance, rate, and time. Let's see. Find the speed of each car. Okay, right there. Find the speed of each car. Okay, well, X is the speed of one and Y is the speed of the other. Of car one. Okay, well, the same thing. Speed, if they're going the same speed, maybe that's just the easy thing. Are they going the same speed? Oh, one's faster than the other. Yeah, so let's say this is the fast one. This is the slow one. All right, let's see. You got to use the 550 somehow. Oh, they're headed towards each other, so they're apart. Let's see. 5 hours later, so there's time here. Let's see. One is 5 miles an hour faster than the other. Okay, so I've got some information I want to do. Also, I think maybe knowing the formula D equals RT. But if speed is a variable, it would be like distance equals X times T or distance equals Y times T. That's the letters that you have. Let's see. I'm going to go to the second equation first. Okay, one fast car is going 5 miles an hour faster than the slow car. The fast car is faster by 5 miles per hour. I see this as the fast car, which is X, is equal to 5 miles an hour faster than the slow car. Okay, there's one possible equation. Wasn't quite as easy as the other two, where you just go X plus Y is equal to another thing. Yeah, not quite as easy. So if I decide I'll use that, and then I go up to the first equation and see what else I can do with maybe the 550. Okay, there's 5 hours. Excuse me. And knowing that distance equals rate times time. Oh, isn't the distance the same? Because let's see, no, actually they're not. The distance that they travel, the total distance, let's do that. Total distance, I'll abbreviate there, is equal to 550. So maybe I say this is distance of the first car and this is distance of the second car. Distance of car 1 and distance of car 2. Let's see. Well, the time they're actually driving, that's another thing that we can do. The time that they're driving is the same. It is the same. The distance is not the same, but the time, because they're both traveling 5 hours. Oh, okay. So that's a 5 right there. I think I got it now. So the distance of one of it, which, okay, let's do this. Distance of car 1 is equal to the speed of car 1 times 5. The distance of car 2 is the speed of car 2 times 5, because they're going the same time. So the distances of these two, which now is 5x and 5y, is equal to the total distance, 550. I think I stumbled on it. That was a hard one. Maybe this one, that's definitely, it was a harder one. Equation. And now I can do, hey, how about substitution? I mean, at this stage you say, okay, how am I going to handle this? I'll do the substitution method because it's set up that way. And I'm kind of out of room, so I'm going to erase this here. If I can find my whiteout. What am I doing? I'm plugging that in here, taking that and stick it right there. So 5 parentheses y plus 5 plus 5y is equal to 550. Distribute 5y plus 25 plus 5y is equal to 550. 10y plus 25 is equal to 550. Subtract 25. So 10y is equal to 525. Now divide by 10 and you get y is equal to 525 divided by 10, which is 52.5, whatever that means. Oh, I know what it means right up here. That's why I have the detail. That's the speed of the slow car, 52.5 miles per hour. It's a little weird, but it's not a bad answer. It's not negative. Most of your problems shouldn't have a negative answer because it won't make any sense, most of them. So there you go, 52.5 miles per hour. How do you find the speed of the slow car? I'd probably go up here. So put 52 right here, 5 miles an hour faster. So 57.5 miles per hour. Speeds.
that was going to be my question. Can we add 5?
Yeah, simply add 5 because you know it's faster by 5. Yep. Speeds of the cars are 52.5. I think it's miles, not kilometers. Yeah, miles per hour. And 57.5 miles per hour.
You don't care which way we write that as long as there's a faster and a slower one? Because I mean, when you wrote it out up top, you have, you know, X and then Y.
I'm not sure if I understand your question.
Well, we had Y as being the slower car, and then we wrote it as the top of Y being 52.5. Just curious if it mattered which way you write that.
You mean if you wanted to write 57.5 first?
Yes.
No, or you want great detail, you could say the speed of the fast car is 57.5 miles per hour, and the speed of the slow car, or vice versa. So just some detail, okay, that's good enough. I don't care which one's first, fast car, slow car, and I know there's a slow one and I know there's a fast one. And I said they're cars, not trains. So you want more detail and want to arrange it differently, Russ? No problem. Go ahead. Hey, Jan.
Yes.
Okay, I have to leave a little before 10. I have an appointment I have to be at 10:30, and I got to give myself some time to travel. So I'm going to pick a couple more, and then I'll just suggest that you in your room. Excuse me one second. I got to turn that sucker off. You wrap up the rest in your room. I'm going to release, or you could actually release the little quiz. I'll leave my Zoom up, so I'm not going to shut down the room. Do you have a way? Can you assign the breakout rooms?
No.
You can't.
No, I
Okay,
don't see it on the bottom anywhere.
Okay, I'll do that before I leave in 5 minutes or so. Okay, I'll do the breakout rooms and leave it for everybody else to work through it. But so everybody knows, I'm not going to shut down your Zoom room and then go to Jan to wrap up the rest of the problems.
Sounds good.
All right, so I am going to pick a mixture problem and a money problem. All right, let's see. Yeah, I'm going to do number 7 and number 9.
Okay.
I'll do number 7 and number 9. And if you can try working through those, if you get stuck, Jan, what you can do is reach out to me, email me, and I'll work it out and send a copy of my worked out problems to you, and then you can distribute it to everybody else.
Okay.
All right, this one here, number 7. How much? Okay, each. Okay, I got 2 accounts, 2 mutual funds. So X is equal to the amount in first account, and Y is equal to the amount in second account. And all together is $24,000. Wouldn't that be nice? So all together, all the money is $24,000. Now the thing I haven't done yet is the interest rates. Okay, the interest rates. So think about it this way: if you had $100, and you're getting 9% on your $100, you're multiplying 9% times the $100. 9% of 100 is $9. So you're taking the interest rate. Okay, so we're going to say this is the first just because it's listed as the first, and 8% is the second. So you're taking the interest rate, which is 9% times the amount of money that you've got in account. And then all together, the combined interest, that means you're adding the 8% amount on that amount of money that you have. You're trying to find all the interest, then is $1,965. That's the hard part. different person. Now what I'm going to do is change it to decimals. That's my choice. Uh, 0.09 x plus 0.08 y is equal to 1965. Some of you saying I don't like decimals, then clear out the decimals by multiplying by 100. You can multiply through by 100 everywhere and you'll clear out decimals. So that'll make it look prettier. I'll multiply this by 100, add two zeros, 196500. And now at this stage, Jan, I'm going to let you wrap this one up because I'm looking at time.
Okay.
Now that I've set up the equation, Jan can finish this one. Okay. Like elimination method would probably be my choice, but you can do it any way you want, Jan. And then finally, I said I'd do number 9. How much water, okay, should be added to 30 gallons of a solution? What kind of solution? Solution that's 70% antifreeze, and at the end, you're going to get a diluted amount of antifreeze. So if you take antifreeze and you throw in water, you're diluting it. So the percentage of antifreeze is going down. So they want to know how much water. We'll do that maybe first. X equals the amount of water. And Y equals the, oh, I already know what that is. 30 gallons of a solution. Oh, they know that 30 gallons. Maybe it's that simple. I don't like the way this is worded. I think this is simpler than 2 equations and 2 unknowns, Jan. I'm going to leave this one off. Meaning, if I can come up with an idea for the second class, then maybe you can send off the results to this class.
Yeah, that's what I was thinking too. Is
All right, so I'll do this one here. This is another mixture one. It needs 15 liters. Okay, here's one solution at the end, 15 liters of an alcohol solution. Here's 1 and 2 solutions that are going to mix together. So you go X is equal to the amount of the 20% solution, and Y equals the amount of the 80% solution. So the total amount of liters is 15. That's the X plus Y is equal to 15. That's the easy one. Now what you got to do is take the percentages, just like the money, like the interest. You're going to take 20% of that solution and then add it to this blend, 80% of this solution. And at the end, you've got 15 liters. So percent, 40% times the amount. See, 20% times the amount, 80% times the amount, 40% times the amount, which is 15. That's the hard part. And Jan's going to finish this one up. Okay. So Jan will wrap those up. In the meantime, I'm going to go and look at the.
I released the
Thank you.
yeah.
Everybody see it's number 10. You guys see number 10, daily quiz number 10, number 10. No heads are shaking up or down there. I'm waiting. Oh, 1 thumb up. Evelyn's got it. One
Yeah,
more.
Annette.
Okay,
Annette
Annette.
is it.
Okay, so I'm going to go breakout rooms. Let's see, 4 to a room. That probably is good, and it eliminates Jan. So when you're done, you can go ahead to see Jan. I will not be here though. If you're looking for me afterwards, I won't be here. So you have to go to Jan after. If you got questions, you got stuck on something, go see Jan. Yeah, okay, here we go. And I'll see you guys on next week, Monday.
Next Monday. Yeah.
No, they're there at the house. I'm picking them up, taking them to the dog room right now. Riley's not in school. She's fine. She's helping her school is, I'll just say not me. So she'll be here with back about 12:30. Yeah, I know. I looked at my line. I grabbed it, thinking it was mine. It's odd enough. No, I got it. I'm looking at it. Yeah. Oh, well. Yeah.